Hello students, this is video 2.9 and the unit title is Logic Lines. Your objective is students will be able to determine special angle pairs. Alright, let's go flippers. So what you want to understand from this video that's really important is that parallel lines and a transversal create special angle pairs. So let's actually label our parallel lines here. So here's line M and line L. And you're going to be told that M is parallel, we know what that means, to L, okay? And the transversal in the picture, like we do transversals in class, is here. So we'll call transversal, we'll make that line R. So that's our transversal. And what it does is it's created these angles, right? So if you have these two lines and now we've drawn this other line that's not parallel, then we have these angles that are formed. So I'm just going to number the angles. So this would be 1, angle 2, angle 3, 4, 5, 6, 7, and 8, okay? And there are special relationships between these angles that we're actually going to talk about right now. First special pair of angles is a linear pair. Pairs are angles that add up to 180 degrees and they share a ray. So an example of a linear pair could be angle 1 and angle 2. Okay? Other examples of linear pair could be angle 1 and angle 3. Again, you see they share this ray here. And then one other example could be angle 2 and angle 4. I have all the examples for now. The next special type of angle could be vertical angles. And vertical angles are angles that are opposite angles, right? So that means they're across from each other. And they're formed by two intersecting lines. So here we have these two lines that are intersecting. Okay, and I'm talking about the actual transversal. We'll call that T here and M. They're intersecting, so they're forming two vertical angles. So we'll call this angle 1. Oops. So this is angle 1 and angle 3. Those angles are going to be vertical. And then we have another pair of vertical angles, which will be angle 2 and angle 4. So they are vertical. And the special thing about vertical angles is that they're congruent. They're equal to each other. They are the same. I'm going to use that little mark there. Then I'm going to use the double mark here to show that 1 and 3 are equal. Next set of angle pairs that are really special are alternate interior angles. Now, alternate interior angles only happen when we have parallel lines. A statement like this one here, M is parallel to L, you cannot assume that you have alternate interior angles, again, unless you have parallel lines. So I call them AIAs because they're alternate interior angles. So alternate meaning opposite sides of the transversal. So if we look at our transversal, we're looking for angles that are on opposite sides, okay? So angles like 1 is on the opposite side as 4. Angles like 5 and 8 are on opposite sides. But we're also looking for a condition that means they're on the inside of the parallel lines, right? Because they're interior. My code, opposite side, inside. So the opposite side would be 1 and anything on this side. But interior would mean it'd have to be inside of the parallel line. So 1 won't work as being an interior angle. We look at 3, 3 is inside of the parallel lines, and we also want 1 that's on the other side. So that means in order for it to be inside the parallel lines, it would have to be 3 and 6. So 3 and 6 are alternate interior angles, and so are 4 and 5. And what do you think in the special relationship between the two of them? You've got it. They are congruent. They're equal to each other. In that definition, that AIAs are two angles on opposite side of the transversal inside of the parallel lines. Consecutive interior angles. Consecutive interior angles are angles that are going to be consecutive, and that means they're actually on the same side. So we're on the same side. So let's put in some numbers here. It would be angles like 1 and 2, right? They're on the same side. 5 and 7, 2 and 4, 6 and 8. But it says interior. So it's looking for things that are on the same side, but again, inside of the parallel lines. So we're talking about angles like angle 3 and angle 5. Angle 4 and angle 6. our two conditions for CIAs, as we call them, same side of the transversal and inside the parallel lines. The special feature of these angles is that they add up to 180. That's right, which means they are supplementary. So if you look at it, I'm saying that angle 3 plus angle 5 equals 180, and angle 4 plus angle 6 equals 180. They are supplementary. Next type of angles are alternate exterior angles. And you're probably thinking, oh, I got this. Alternate again, meaning alternate side of the transversal. So angles like 1 and 4, 5 and 7, they're on opposite sides, but they want exterior. So this time they want them outside of the parallel line. So not on the inside, but on the outside. So that would be angles like angle 1, and you're probably thinking, right, yes, angle 8. Pairs like angle 2 and angle 7. That's correct. Just to be clear, our conditions are the opposite side of the transversal. Okay? So again, opposite side and outside of the parallel lines. Again, 1 and 8 and 2 and 7. And the special feature of these angles, you guessed it, they're congruent. They are equal. Therefore, angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7. Last but not least, we have consecutive exterior angles. Consecutive means they're next to each other, right? Next door neighbors. So that'll be things like 1 and 3 and 2 and 4 next to each other. 1 and 2, 3 and 4, 1 and 3. But it says exterior. So they're looking for things that are next to each other, but outside of the parallel line. So we're talking about angles like angle 1 and angle 2, or angle 7 and angle 8. Those are consecutive exterior angles, and there are our two conditions, are opposite of parallel lines, right? Outside of the parallel lines, and same side of the transversal. And the special feature of these angles, and a lot of you are like, oh, wait a minute, that looks like a linear pair. You're right. So if it's a linear pair, they add to 180. So they are also supplementary. That we want to do, and those are corresponding angles. And corresponding angles are really cool. I kind of think of it as if I were to take a knife and slice this picture here, right there, and I were to say to you, hey, if you look at angle 1, what angle is in the top left corner on the bottom parallel line? You would say, oh, angle 5. It directly corresponds. If I were to pick up the entire angles here, 1, 2, 3, and 4, and place them right on top of these angles, which one would lay right on top? Well, those are corresponding angles. So we'd have angle 1 would be corresponding with angle 5. And you see me marking the congruent mark because they're also equal. You'd also have angle 2 with angle 6, right? Top right, top right. You'd have angle 3 with angle 5, and you'd have angle 4 with angle 8. And the special feature of these angles is that they are congruent, okay? So the condition for corresponding angles is that they are in the same position. Same position. Example number 1 says, what are angles 2 and angle 6? Given that L is parallel to M. Can't do anything without knowing that. So that is a condition given to you. So number 1, angle 2, we find it in angle 6. Well, they are inside of the parallel lines, right? And they're next to each other. But they're not on the same side, so they can't be CIAs. But they are next to each other and then the inside, so that means the only thing we can really find here is that they are a linear pair. So linear pair. Number 2 says, what are the angles 1 and 6? So here's 1 and here's 6. And again, they're on different sides of the transversal, so they're alternate something. But we've got one inside the parallel lines and one outside. And there isn't really a situation for that other than they're opposite angles and they only share that one point. Oh, these are vertical angles. And remember, vertical angles are congruent, and that linear pair back there added to 180. Just want to add that in. Just be thinking about that as you work through these. And number 3 says, what are the angles 1 and 3? So here's 1, and here's 3. And we look, they're on the same side of the transversal, so they're consecutive something or same side. And if we look at them, up here's 1, here's 3, but they're not both inside the parallel lines. So they can be consecutive interior. And there really is no, the consecutive exterior would mean they'd be outside the parallel lines. But they're in the same location, right? If I were to cut right here and slice this in half, 1 would fit on top of 3. Oh, these are corresponding angles. And corresponding angles are congruent. So they're the same. So here's your secret hot question for tonight. It says, what are angles 2 and angle 3? Ooh, what do you know about 2 and 3? Where are they in relationship to the transversal? Where they are in relationship to the given statement, which is that L is parallel to M. See you tomorrow.